Hello everyone. So today we are going to discuss about the coding interview again. It's a second part of my previous video, and in this video what we are going to discuss. So I will share with you my kind of a format how you should prepare for the coding interviews, and truly saying, if you do this kind of a format on daily basis on your job, it's pretty helpful. So we will start, and then I will share with you more thoughts around that. Okay, so before going to jump in, there are two things we need to differentiate in a coding interview, and generally when you are going to implement your task on your job. So you should understand what is the difference between an algorithm and program, and I wrote some points, not all, which are enough to understand. And most of the time, if you graduated now, most probably you can understand easily. But if you are in a industry from like long time, 4 5 years, and you are working with those companies where they have a different kind of a culture, where their expectation is only you will complete your tasks, then maybe you need a revision. So we will revise this. So algorithm, in case of an algorithm, you always design, you never implement. And what is design means, like you have a problem, and now you start thinking in your mind, okay, how should I design this? And you can design on a paper also, you can use any tool, maybe you can make a kind of a graph, okay, maybe flow chart, or anything, it depends on you. Then the design, or maybe you can use any language, which like kind of a pseudocode, so which is mostly everyone knows. And in case of an implementation, it's a proper code which is going to be executed on a machine. So there is a very big difference, both of them. In case of a design, again, you are going to think this is your problem and how you will solve. And in that thinking process, you will figure it out. Okay, I will use because it's a backtracking problem, I can understand, so I will use a recursion. Okay, it's a loop and I can improve, so I can use the iteration. So iteration, okay, then what else? Maybe I need to jump, maybe I need to decide. So it's like the kind of, you are thinking around that, and then once the algorithm design is there, then you can take the next steps, we will discuss later. Okay, so design and implementation, there is a difference. In case of an implementation, you are writing code now, and most of the time we start doing these things as a programmer, as an software engineer. We start doing this, we left this, we start ignoring this, and our brains are now stuck to this, and now we start facing issues in any interviews also, especially in these kind of interviews where they are expecting you should, and there is a reason why you do this, we will discuss that. So implementation, mostly every programmer is doing, every freelancer is doing. There is a you have a problem, you are going to start writing code. Once you write code, you run, you execute, and then now you start testing. And then when you do testing, most of the time you face some bugs, you resolve those, but there are always hidden bugs, the states, because you never thought about that, you are start implementing directly. So there are many edge cases, many cases which you don't understand, then later you start getting that once your app is in prod, and or maybe QA is testing for you different scenarios. So implementation has that issues. But once you think from the design perspective, it always helps, because you manage yourself, and it's pretty difficult if you are stuck with this approach. It's not easy. You need to make sure yourself, you should not go on a laptop, sit somewhere far away from the laptop, and then think. And sometimes you feel it's kind of a childish thing, you understand it's a loop, simple, but still try to spend time, and you will start feeling, no, it's not a something childish, it's pretty amazing. And then once you think, you will implement something, okay, this is my thing, but where it's going to be a part of that some program, because always your task is always a part of a bigger feature. So you try to think, okay, that is a block which is going to put there, how many inputs are coming to this block, you start thinking about those. Okay, this is your feature, from here on how many places your output is going. Okay, now your feature, now you can think about, okay, that feature, how that is going to work. So we will discuss this. So design is done, implementation is done. That one is language agnostic. Language agnostic means the programming language. Still pseudocode is kind of a language because human beings share knowledge by using maybe language, not maybe, we use language to share our ideas. So language agnostic means it's not something like Java, C++, but the program implementation is a language specific, Python, Ruby, and we will come to later. Then independent of language, uh, here we have a dependent on a hardware. This is independent of a hardware. Sorry, I wrote language. So when you are thinking about this independent of hardware, then the problem is how you will measure the performance. In case of a program that is dependent on a hardware, so every hardware have their different power, so you can do benchmark, but on different machines you have a different answer, but still, so for that, which something on dependent on a machine or a hardware, you have two things: execution time and memory, how much memory is taking. So for that we have units. So basically, if you go deep down, sometimes people do, so they are trying to understand, okay, how many cycles, CPU cycles it take to the load one instruction, and from there you will take up, and then you will move into the nanoseconds or milliseconds according to that. Okay, your algorithm is taking that time of these are the instructions, it's 10 instructions, one instructions take maybe 4 cycles, so it's going to be 10 cycle, 10 multiplied by 4, 40 cycles, and our current CPU take 1 nanosecond to complete 40 cycles, so it's been 1 nanosecond. But tomorrow you have a CPU which take, for example, 80 cycles per nanosecond, so it means your algorithm, so it's kind of a, that's why it's a dependent on a hardware, and you execute in this way, so you measure by using that. Then memory also, you can, we measure memory in the form of bytes, bits, megabytes, gigabytes, so you can easily understand, okay, so this is the algorithm where I'm going to take an integer array which always have, for example, 10 values, so 10 multiplied by 4, it's 40 bytes. Okay, then I have this loop, then this is the function, this is not the variable, it's only the temporary memory, and then, so it's, I'm discussing a too deep, but mostly we don't discuss in when we are working as a software engineer for the application layer, mostly we don't think at that level. But if you are working in infra or data center, then I have a feeling in my I read on a lot of places people are doing this, and it's very important for them, because if they have a data center where they are doing a lot of work, and if they save only 10 cycles for something and they have millions of users, it impact a lot, it save a lot of money. Okay, so now coming to the algorithm. So in case of an algorithm, how we measure, so we have a functions, time and space. So there are two definitions. One definition is which is a mathematical definition of time and space, and mostly we use big O notation. But what I found in software engineering, mostly how we discuss every day with my colleagues or when we are reviewing, we are not mostly taking care of the mathematical definition. We mostly use, okay, big O of n, so we have some kind of an idea what does that mean. It's not, most people are really know, okay, what is the, it's a upper bound big O, what will be the lower bound of this, what will be the big of theta. So I will discuss with you what mostly we used to do in every day, not the mathematical definition. We will discuss this in a separate video. So we will measure in the form of a time and space. Now coming back to the interview. Once you are in interview, or when you are writing your own code on daily basis, try to go with this approach. So in an interview, once there is a problem, you need to design first. Don't jump into the implementation. If you jump into the implementation, it's a negative signal, it's a negative sign. No. So design means you will discuss with him, okay, now I understand your problem, I'm going to solve this by using two loops. I will go with the nested loop, and then I will do this and this. Okay, and then maybe he will ask you, can you optimize first before going to implementation? And how he will ask about the optimization, once you will discuss design, then you also will discuss time and space. It's very important. And we sometimes we also memorize, okay, big O of n means when we have a one loop. If I have a nested loop, it's a big O of n square. When I have this, it's a n log n, it's a log n, which is okay, it's not like bad, but there is no need to memorize those. you can learn easily by seeing what you design. So that we will discuss separately in a big O series. So once that is done, maybe interview will ask you, there is a one more approach, maybe we can optimize, and then you start discussion. Okay, maybe if I do maybe one loop, I want to move to the nested loop into one loop. It means now there is a trade-off, because before that you are using CPU intensive algorithm, two loops. If you are going to remove one loop, it means now there will be trade-off between the memory, so you need a more space. Most of the time it's like this. Mostly problems where you have two loops and you want to remove one loop, you need to use extra memory to save some information. Maybe it's a frequency of some alphabet or anything, so kind of that. And then you can design. Then you will, once you design, you will say, okay, before that I have a big O of n square and my space is big O of 1. Now this time my time will be big O of n, but now I'm going to take big O of n space. And now it's a trade-off, but if he is happy, yeah, you are happy. So if both you are happy, you can jump into the implementation part. Now here you will choose the language, you will start writing your code. Here the most important thing, what you design, you need to map the exact same thing in the implementation. What happened, it's the most difficult part most of the time on daily basis, because we are only doing this, we don't care about that. And when we have an interview, we discuss this, but what we implement, that has no relationship with this. Like you will discuss with me, maybe I will do this, I will use the BFS or a DFS, or I will use the quick sort. But once you start writing code, you start writing code for the quick sort. Or maybe you are not able to implement your backtracking recursion, because the mapping is a pretty difficult. This one is a human thought, and this one is a machine. You are going to give the instructions to the machine, and for that you need to prepare, you need to practice a lot. And here you need to practice a lot, and then you will understand. Okay, so there are two only options. For example, you are going to preparing for the interview, then you will start now by using some third party platform, maybe lead code. But if you start doing the same thing on every day on your job, you don't take some task which you have a task, try to convert into the problem, start thinking, okay, that is a problem for me, it's not a task, and how I need to solve that. Design in your maybe mind or maybe on a paper, and then after try to think what will be the time and space. Can I improve that? If you can, it's pretty good. If not, still it's okay. Then move to the implementation. Now you will implement what you decided in the design. If you can't, then go back and then check, okay, what is the issue. From there you will start getting the patterns. Oh, okay, when I need to design this, it means it always map like this in a code. So once that is done, you are here. This one is also language specific, so you already chose one language. Okay, I will write code in C, C++, Java. Try your best to be good with your language. The APIs, understand your APIs, and there also time and space. Like, okay, if you are going to write a substring function, you should know how much it is going to take time. So maybe there is no need to write a substring function, but you can use that asking by, okay, can I use? So once that is done, so that is language specific thing. Then also dependent on the hardware language, and then execution and memory in bytes. So basically most of the time, sorry, if you discuss this time and space, this is kind of a useless. But still, if you understand, if I understand, I always throw. Okay, basically we did this, so it means it is going to take 4 megabytes in memory, because I have a array of 10 integers. It's going to multiply by 4 bytes, and this and this and this if you have time. And the execution time, if you really good with the hardware level things like CPU cycles, how it works, so you can also discuss that. It's in my opinion, it's a plus point in my opinion. Like you really understand the CPU also. Okay, if you have a one core with this gigahertz, it is taking this time, the CPU cycle. And so kind of if you have some knowledge, you should share, and it always positive in my opinion. It's not bad, but it is optional. What is important? Never jump into this part. Always start from here, design. Once the problem is designed, that is always language agnostic. because sometimes companies ask you to come to the office and they give you the whiteboard. So they mostly you can discuss theoretically. Maybe you can ask, okay, I'm writing kind of a pseudocode, and then you start design. Once design is done, you can discuss the time and space. Then you will move here. Now the implementation start. Language specific, you chose the language. Okay, I'm going to use C++ language in syntax. Then use the C++ and then after that here you will end. So this will be the direction, coming here, then coming here, then moving here, then this. And the best part is, if you do this flow every day in your job, there is no need to remember these steps, because sometimes what happened, you start practicing 1 week before the interview. Once you are an interview, there is a pressure, and your brain is still not there is you don't have this habit. So what will happen, you sometimes mistakenly jump into the implementation. You are really curious, you understand the question, you want to implement, which is a good not sorry bad approach. Still you need to go to design, because the interview don't know about anything about you. So you need to tell him, okay, this is my approach, how I think, how I write my code, this step. And in this way he really understand, okay, what you are saying you really know. And once you start practicing like this, one day there is no need to sit far away from the laptop, there is no need for a page. Your brain will start thinking in that way, okay, this is a problem, I first design. And you will start designing in your brain, that once you are done, your brain is also is ready to understand, okay, it's a time and space, what will be the time and space. Once that is done, then your fingers will start writing that code. It take time if you are not doing now, but it's not impossible, it's pretty possible. Only you need to take care of first 6 months or 4 months. Don't be uh, don't try to jump in every time in an implementation. So I hope I shared some information.